Hello again. Now we have a question 14, and this question is on the topic of coordinate geometry. Okay, so here in the first part, we have a diagram here, right? And we have 2 points, A and B, are shown on the diagram. Okay, so in the first part here, it says write down the coordinates of the point A and the point B. Okay, so let's see what we have. We have the diagram here, and we have 2 points. This is point A, and this is the point B. Okay, and here is the x axis, and also here is the y axis. Okay, right? So we need to find the coordinates of this point in terms of x and y values, and also the coordinates of this point also in terms of the x and y values. Okay, and remember that usually when we write the coordinates of a point from the diagram, we usually use what? We write it down the x value and the y value here, meaning that we need to just check the x axis and the y axis. We see the values, the coordinates of the point on the x axis and also on the y axis. Okay, so for point A, what we have, let's see, this is point A. Okay, so if we see that point A has a coordinate on the x axis with a value of 3, as you see here, right? Okay, this is the 3. Okay, and also the point A has a coordinate on the y axis, okay, on this y, okay, with the value of what? Of 2. Okay, so we just need to do something like that. Okay, so should be the x coordinate of this point is what? Is 3, and the y coordinate of this point is what? Is 2. So we just need to write down here just a 3, which is x, for example, and here 2. Okay, and about the point B, we need also to find the coordinates of this point. So for point B, the x coordinate of this point is what? Is 3. So we just, if we we refer to the point on the x axis, we have a value of 3, right? So we have a 3 here, we have a 3, right? While on the y axis, you see, we're going down, like this in the negative value. So here is the coordinate of the point B on the y axis, which is -1. Remember that here is negative -1. So here we should write -1. Okay, so here for point A we have 3, you can say 3, and here we have 2, right? And for the point B we have also 3, the coordinates on the y axis, okay, and we have -1, the coordinates of the point on the y axis. Okay, and here in the second part here, we need to write down the length of A and B points. We need to find the distance between those 2 points, the A and B. Okay, so here is the solution, is quite easy. Why? Because we have a straight line here from A to B, or from B to A. We have a straight line, so we just need to count the number of boxes here. So we have 1, 2, 3, right? So we can just write down, we have the length of A and B is 3, so we just say 3. Okay, but also we have another solution, okay, another way to find the solution by using the the formula to find the length of 2 points, between 2 points, A and B from the diagram. Okay, let's use the formula for that. So as you know that point A with coordinates of 3, 2, right, and we have point B with coordinates of 3 and -1. Okay, and remember that here we have x1, right, and here we have y1. Okay, and here we have x2 and we have y2. Okay, and the formula, as to find the length of 2 points, okay, what we can say, something like this: the length, for example, A A and B points, we use the square root, so we have a square root, long square root, right? So we need to do something like this. So here's the formula that we have to use. So we have x2, right, minus x1, then squared, plus y2 minus y1 also squared. So that's the formula when we need to compute the length of 2 points from the diagram, right? x2 minus x1 squared plus y2 minus y1 squared. So now we write down the values. Okay, so with the square root here. So what is the value of x2? x2 we have 3, right? So we have, say, 3. Then we take away x1. x1 is what? It's also 3, right? We do squared here, right? Plus, now what we have? We have y2, which is what? Minus 1. So we say minus 1. And then we take away y1, which is what? Which is 2. Okay? Minus 2, right? Also squared. Okay? And the answer here is quite simple, as you see. Why? Because, you see, we have 3 minus 3. This gives me 0. And 0 squared is also 0. So we have only this term. This term is gone here. So we have only this term. So what we have? Minus 1. Minus 2. We have minus 3. Squared minus 3. Squared means what? Means we have 9. Okay? Then we take the square root of 9. We will get 3. Okay? So we just need to write down here as 3. Okay? So the correct answer is a 3. So we say 3, right? And that's the correct answer from this part. Okay, remember that in this part we have 2 ways to work out the solution. Either we use the the number of boxes here, right? Let's see. Number of boxes here. You see? Because we have a straight line. Okay, or we can use this formula, okay? The proper formula to find the length of 2 points from the diagram, coordinates, okay? And here in this part here, okay, it says the point C is minus 4, 2. Okay, so we have a point C, and this point has a coordinate on x-axis with a value of minus 4, and the coordinate of the point on the y-axis is 2. Okay, so we need to plot and label the point C on the coordinate diagram above. Okay, so remember that we have a point here. So we have x coordinate and we have the y coordinate. Okay, minus 4, 2. So we go up to the diagram here. Let's see. Okay, so the x coordinate of the point is minus 4. So where is minus 4? This is the x-axis. Okay, so minus 4, it should be on this side, right? So we have minus 1, minus 2, minus 3. So he's minus 4. Okay, so we have here, and then we need to check the y coordinate of the point. So the y coordinate of the point is 2. So we have to go up by 2. Okay, so 1, 2, right? So this is the point. Okay, okay, here is the point C, and we have the x coordinate of minus 4 and the y coordinate 2. Okay, remember that we go up. Okay, so let's write it down. For example, here we just need to plot and label. So we can say here is the point, right? So we just label the point. We can say point C. Okay, that's point C. Okay, and on the question down there, we can say just C above, for example. Right, C above, right? Okay, and that's the correct answer from this part. And now here in this part, what we have, okay, we need to work out the slope of the points B and C. Okay, B and C, the slope of those 2 points. And we need to give the answer as a fraction. Okay, so let's see the diagram here. Okay, here is the point C and this is point B. Okay, so we need to work out the slope between those 2 points. Okay, so let's draw the line between those 2 points. Maybe we can use also the dotted line style, something like this to make it easier, right? So here is, okay, so we have the line between point C and point B. And as you know, to work out the slope of 2 points, we can use the formula of run and rise. Okay, run and rise. So the run from point C, we have 1, 2, 3, 4, 5, 6, 7. Okay, so the run here is 7. Okay, and the rise is what? From here, right, to the point B, we have 1, 2, 3. So we have 3. But remember that we are going down. Since we are going down like in this direction, so we have to use minus 3. Okay, minus 3. All right, so let's do it here. Okay, so here is, we can say something like this. The run is 7 and the rise is what? Is minus 3. So we write them down. 7 here, right? The run is 7 and the rise is what? Minus 3. Okay, and now to find the slope of this, we can just say the slope of those using the run of rise. We can say the rise over the slope over the run. So we have minus 3 over what? Over 7. Okay, so that's the slope. Okay, but also we have another method to do that. Okay, so let's work out the another method, okay, which is the the proper formula, from the log table you have. Okay, so let's see. Let's write down the points. We have point B, okay, which is a 3, then minus 1. These are the coordinates of this point. And we have C here, which is what? With the coordinates of minus 4 in the x-axis and what? And 2 in the y-axis, right? So here also maybe you can say something like this. Here we have x1, we have here y1, right? And here we have x2, right? And we have y2. Okay, and the formula for that, to find the slope, as you know, right? So we can say slope equals, as you know here, the formula, we say y2 minus y1 over x2 minus x1. Okay, and we write down the values. Y2 is 2, then we take away y1. The y1 is what? Is minus 1. Right, remember that we need to take the value of the y-axis coordinate and also with the sign, with its sign. So minus 1, remember that. Okay, and here we have x2 is what? Is minus 4, right? Minus 4, and then we take away the x1. x1 is what? Is a 3. Okay, you can use the calculator to get the answer. So here 2 minus 1 we have here should be what? Should be 3, right? And then minus 4 minus 3 we have minus 7. So we can say 7 here, we put minus in front. Okay, so that's the correct answer from this part. Now here in part B, we have a diagram that shows the triangle PQR. So PQR, okay, and we have the length of the distance between the point P and point Q is 24 meters. So here is we have 24 here, and we have also here the length of QR is 12. So here is, okay, between those 2 points, okay, and we have an angle here with a size of 90 degrees. So the angle is what, PQR. So here is the angle with the 90 degrees, okay, and we have another angle X, okay, here for point P, okay. So let's see. In the first part here, we need to work out which of the following is correct, and we need to tick one box only. Okay. Now, if we look at the diagram here, we can see that for this angle X, this side 12 meter represents the opposite side. Okay, side of the angle X. So we have the opposite side of the angle X. And also here, this side, PQ, represents the adjacent side of the angle X. So here we have the adjacent, okay? And also the last one here, we have the hypotenuse of the triangle here, hypotenuse, okay? So from the choices here, we have a ratio of 12 over 24, all of them, 12 over 24. And if we look at the diagram here, if we say 12 over 24, okay, and that means that we are saying like opposite over the adjacent of the angle X, okay, opposite over adjacent sides of the what, of the X, okay, and this means that we have the tangent of X, tangent, okay, so we need to tick this box only, okay. So we have the tangent X is 12 over 24. Okay, and here in the second part here, we need to use a calculator to find the size of the angle X now, the size of the angle, and we need to correct the answer to the nearest degree. Okay, so let's see what we have here. We know that tangent X, we have tangent here, right? Tangent, we say X equals 12 over 24. We got it. Okay. If we need to get the X now, this value here, we have to use the inverse tangent of this value here. Okay. Because we have tangent X equals 12 over 24. If we need to find the size of the angle X, we need to get to find the inverse tangent of this value, of this fraction. Okay, so we can say here, we say X equals what? Inverse tangent, right? Inverse tangent of this fraction, 12 over 24, right? And now we can use the calculator. So what we say, here is the tangent button here. Okay, if we need to get the inverse of the tangent, we have to use the shift button here. Shift tangent, we get inverse tangent, and then we use the fraction button here, and on the top we have 12, down arrow we have 24, and the right arrow, and then the brackets, we get the answer, which is 26. We write down 26. 26.565, right? And remember that we need to correct the answer to the nearest degree. Okay, so we have to look at this number here, the number after the decimal point. So we have 5 or more, and that means that we can round this number to be 1 to add it to the term before the decimal point, since we have 5 or more here. Okay, so here what we have 26, and then plus 1 from this term. Okay, and that gives me what? An answer of 27. So we write it down like this. We can say 27 degrees. Okay, and that's represent, this represents the correct answer from this part.